In order to satisfy the shipping needs of the businesses and manufacturers in a city, FedEx must be able to transport at least 120,000 pounds of goods each day. To accomplish this task, FedEx will be using two types of trucks: an express vehicle and a heavy hauler. Each express vehicle requires a crew of only one person and can carry 5,000 pounds of cargo. The heavy haulers require two people per vehicle, but they can hold 15,000 pounds of cargo. Each day there are only 15 express vehicles and 12 heavy haulers available. On any given day, there are at least 18 workers available to operate the trucks. If the operating costs per vehicle are $74 for each express truck and $111 per heavy hauler, how many of each vehicle should they use to minimize their cost? What is the resulting cost? X equals the number of express trucks and Y equals the number of heavy trucks.
Okay, so these are our constraints. Our first one being 5,000x plus 15,000y is greater than or equal to 120,000, and this is because they need the total amount of goods shipped to be greater than 120,000 between the two types of trucks. And x has to be less than or equal to 15 because they only have 15 express trucks available, and x has to be greater than 0 because you can't have a negative amount of trucks, and y has to be less than or equal to 12 because there's only 12 heavy haulers available, and y has to be greater than or equal to 0 because again you can't have a negative amount of trucks. And our last constraint is x plus 2y is greater than or equal to 18, and this is because each heavy hauler requires 2 workers, and each express truck requires 1, and the total number of workers has to be greater than or equal to 18.
So this is our graph, and our x-axis is the number of express vehicles, and our y-axis is the number of heavy haulers. And this is our feasible region, meaning that any possible solution is going to be within that shaded region or on our lines. And for corner points, we have 0, 12, 5, 12, 15, 12, 15, 3, 6, 6, and 0, 9. And each of these lines represent one of our constraints. So this line going like that right here is our constraint of how many workers we have to use, and this other line represents the amount of goods that have to be shipped, and this line is because we only have 15 or less express trucks, and this other line up here is because we only have 12 heavy haulers to use, and our optimum solution is going to be one of these 5 corner points.
This is our objective function, f of xy equals 74x plus 111y, and it's this because we're trying to minimize expenses, and it costs $74 to operate an express truck for a day and $111 to operate a heavy hauler for one day.
For our final solution, we came up with 0 express trucks and 9 heavy haulers because when we plugged this x and y into the objective function, we were able to come up with the least amount of money, which came out to $999.
The original objective function was f of xy equals 74x plus 111y, and that came out to 0, 9, and our altered one is f of xy equals 30x plus 100y, and that came out to the corner point 15, 3. We greatly decreased the x value while only slightly decreasing the y value. And again, the objective is to minimize outgoing expenses.